to my channel Buzz with MXN. Today we're going to discuss a very important topic, that is the OSI model. What the OSI model is, what it does for computer networking, and why is it very important for the network engineers, and how it basically helps us to troubleshoot various issues on various layers. So this video is about that. So if you're aware or not aware about the OSI model, if you have slight understanding or no understanding at all of the OSI model, this video is for you. So if you want to understand the basic concepts of the OSI model, let's get started with them. So OSI model basically stands for Open System Interconnect. This is not a physical model. It's basically a conceptual model that was created by the International Organization for Standardization. So what it does, it basically enables different vendor systems to communicate over the internet. An HP laptop communicating with a Mac device over the internet, how is it possible? It's made possible because of the OSI model itself. And it is basically based on the concept of splitting up the communication system into 7 abstract layers, each one stacked up on the last. So to understand the model, the OSI model, we need to understand what it's comprised of. It's basically comprised of 7 layers, which are basically having which run basically different protocols at different layers, and those layers basically comprise of the OSI model. Starting with the topmost layer, that is the application layer, which when you are opening your browser, the protocol that is being used, the layer on which the browser is basically working on is the application layer. It's basically a human computer interaction layer, where you basically how do you basically communicate with the computer? You open, or you want to communicate with your friend over the internet, or you want to visit a particular website. How do you do that? You open a browser and you surf the internet. So the browser, or you're trying to send an email to your friend, or you're just trying to share a file over the internet. How you're doing it? You're doing it with the help of the application layer itself. So human computer interaction happens on this layer, where the application can access the network services like mail services, browsers, FTP servers, etc. The next layer, or the 6th layer, is the presentation layer. What it does, it basically ensures that the data is in a usable format and is where the data encryption occurs. In this layer, what happens is that the raw data that is sent from the application layer, it basically encrypts that data in order to send it over the internet, so that no hacker or no third party present over the internet, when we basically share this information over the internet, can hack it or basically see it. So what it does, it basically encrypts the data. And this encryption protocol is universal on all the end devices, because when you encrypt the data and you are sending it over the internet, and when the host on the other end receives this data, should be able to decrypt the data, what is basically sent along the to that particular host. So this helps in encryption as well as decryption, and is present on both the sending device as well as the receiving device as well. Coming to the session layer, it basically what it does, it maintains the connection and is responsible for controlling ports and sessions. So ports, like you communicate, you have running a web browser and using the HTTP protocol, you're using the port 443 or something like that. You using a UDP protocol, you using the port 58 or 53. So these are the ports that you're basically, it helps in controlling the ports that you're using, and establishes a session with the from the client who is sending the data to the other machine who is receiving the data. So it basically establishes a session or the link of connection between one device to the other. The 4th layer is the most important layer, is the transport layer. It basically helps us transmit data using protocols such as TCP and UDP. These are basically used for flow control, how much data should flow at a particular rate, and basically helps in segmenting the data along the way. So when it receives the data from the session layer, from the upper 3 layers, when the data is received, it basically fragments the data or segments the data into smaller parts so that it can be shared over the internet. 3rd layer is a network layer. It basically decides the physical path the data will take, like which route the data is going to take to send from one host to the other host. Data link layer basically defines the format of data on the network. And the last layer, that is a physical layer, it transmits a raw bit streams over the physical medium, like it sends the data in the form of bits, like 101010 over the internet. Okay, so this was something related to the OSI. And why does the OSI model matter? Why is it useful? So as I stated earlier, it basically helps us to troubleshoot the issues layer by layer. So if you need to identify, it basically helps the network engineers to identify on which layer the issue is, and they basically can troubleshoot on that layer, not troubleshooting the whole of the stack of the OSI model. So it's very beneficial for the network engineers to troubleshoot the issue. OSI model can help to break down the problem and isolate the source of trouble. Like there's some issue with the data link layer, or some physical connectivity is not there, or there's an issue mismatch of the IP, or IP conflict is there. So all these issues can be troubleshooted based on the OSI model layers. So if the problem can be narrowed down to a specific layer of the model, a lot of unnecessary work can be avoided. As I think it's very much clear. So if the issue is isolated, most of the unnecessary troubleshooting can be avoided in this case. What are the 7 layers of the OSI model? The 7th layer, the topmost layer, is the application layer. This is the only layer that directly interacts with the data from the user. Okay, software applications like web browser, email client rely on the application layer to initiate communication. So as you said, as we have already discussed this, we use the make of browser, we make use of the browsers, or we make use of Google uh, Outlook or Gmail's Google Mail services. All these compliance are run on application layer. Application layer protocols include, which other protocols are included, are HTTP, SMTP, FTP. All these protocols are run on the application layer itself. Coming to the next layer, that is the presentation layer. The presentation layer is the layer 6 that makes the data presentable for the application to consume. So what it does is basically uh, defines the data in a presentable way so that it can be transferred over the internet. The presentation layer is responsible for transmission, encryption, and decryption of compression of data, basically. So how the data is compressed when it is received from the application layer, how it is translated, how it is encrypted, so that it can be sent over the internet, and no hacker or no third person party can basically decrypt what is being sent. So it is used for that. So it also enforces same encoding methods, avoids devices across devices. So layer 6 is responsible for translating incoming data into syntax that application layer of the receiving device can understand. So as I stated earlier, the sending device and the receiving device both have the same presentation layer protocol through which they are able to encrypt the data as well as decrypt the data in a similar fashion. Responsible for compressing data it receives from the application layer before delivering it to the layer 5. So it basically compresses the data from that is basically received from the upper layer, and then shares the data to the layer 5. That is the session layer. This helps improve the speed and efficiency of the communication by minimizing the amount of data that will be transferred. So when the packets are less, when the data sent over the internet is less, it will take less time, and it basically improves the efficiency while communication over the internet. So this was about the presentation layer that we had discussed. Next is the session layer. Talking about the session layer, this layer is basically responsible for opening and closing communication between two devices. You want to communicate with your bank server, there will be a session that will be activated when you want to basically log in, when you basically log into your with your credentials over your bank services or net banking. So this session layer comes into play at that time. The time between the communication is opened and closed is the time between when the communication is open and closed is known as a session. So when the session is basically activated, it is and closed. This is basically done via the session layer itself. The session layer ensures that the session stays open long enough to transfer all the data being exchanged, and then promptly closes the session in order to avoid wasting resources. So it's pretty much clear. Also, the last point is ensures the check the checkpoint to keep track of transfer data. You must have seen that while you download a particular game or a particular movie from any of the browsers, and suddenly the internet connection drops. So, for example, you have downloaded 50 MBs of your game. That is basically a 100 MB game. So what happens when the connection drops? When the connection drops and you reconnect back to the internet and try to re-download it, it starts downloading from the same exact point from which it has left. For example, 50 MB have been downloaded, it will just download the remaining 50 MB, not starting from the, not basically going from the start. So this is the checkpoints that are basically enabled by the session layer, which helps in reducing the downloading form. Talking about the transport layers, the most important layer where the transition between the upper layers and the networking layers happen. The layer 4 is responsible, the transport layer is basically responsible for end-to-end communication between two devices. So it helps in the end-to-end communication between two devices. This includes taking data from the session layer and breaking it up into chunks called segments before sending it over to the layer 3. So when it receives the data from the session layer, what it does, it basically breaks up that data into smaller chunks that is called segments before sending it to the network layer. The transport layer on the receiving device is responsible for reassembling the segment into the data the session layer can consume. So when the data is sent from the host, which basically segments the data in smaller parts, the transport layer on the receiving device reassembles all the data that has been segmented and then puts it into a frame and into a data and sends it above to the session layer, to the presentation layer, and to the application layer for the user to see. The transport layer is also responsible for the flow control or error control. And also, for example, you're using a device and you have a downloading, so you can only download up to 10 Mbps, and this ISP is shooting out traffic at 100 Mbps. So what it does, it basically enables a window of and tells the server that I can only accept at 10 Mbps data. So please establish a session where you only send 10 Mbps of data so that I can download it at my pace. So this basically helps in the flow control and error control. Also, that there are some packets that are missing, helps in the error control as well. So flow control helps sync while data transfer rate between sender and receiver. Performs error control. TCP and UDP protocols are used. In this transport layer, what protocols are used? That is transmission control protocol and user data connect protocol. These are the protocols that are used in the transport layer. Talking about the network layer, this is the third layer. The network layer is responsible for facilitating data transfer between two different networks. So if you want to send data over the networks between two hosts, you make use of the network layer. Basically, if one client is on a different network and the receiving client is on a different network, we make use of the network layer. Otherwise, if they are on the same network, we don't basically have to use the network layer. If the two communicating devices are on the same network, then the network layer is unnecessary. The network layer basically what it does, it breaks up the segments from the transport layer that it receives on. There are some packets, there are some segments that are received by the layer 3 network, by the layer 3 protocol from the transport layer. What it does, it further basically breaks down into them into smaller parts or smaller units called packets. So the terminology that we used in the network layer when it basically basically divides the frame into segments into smaller parts, it is called as packet, and one on the device sender, and reassembling the packets when the receiving device. Okay, for example, if the device is sending these packets over the network layer, it basically divides the packet into smaller, it basically divides the data into smaller packets, and then when it is received by the receiving client, it basically reassembles those packets and sends it above to the above layer, that is the transport layer. Um, the network layer also finds the best physical path for the device to reach its destination. It's also called as routing. So you must be aware as to how we send the data from one subnet or from one network to the other network. It is called as routing, and This is basically what it does. It basically defines the best path that the data can take from reaching from one client to the other client. Network layer protocol includes IP. What the protocol that are basically used on the network layers are IP protocol, IPv6, IPv5, and ICMP, IGMP, and IPv suite that are being used as protocols. The data link layer, basically what it does, the data link layer is very similar to the network layer, except the data link layer facilitates data transfer between two devices on the same network. So here the networks are not different, networks are same. This also helps in the data, uh, basically helps in the data transfer. And the data link layer takes packets from the network layer and breaks them into smaller pieces called frames. In the network layer, we used to call it as packets. In this, we call this as the basically the fragmentation of data. We call it as frames. And like network layer, the data link layer is also responsible for flow control and error control in the intra network communication. So within the network, the communication happens with the data link layer, and switches basically operate on this layer, that is the data link layer, and works on MAC addresses. The last layer would be the physical layer. The layer includes the physical equipments involved in the data transfer, such as cables and switches. So after the data link layer, the frames are basically divided into bit streams like zeros and ones, and they are basically sent over through the cables to the receiving host in the form of electrical signals, or in the form of light signals over the optical fiber. So this is what the physical layer does. This is also the layer where the data gets converted into bit streams, which is a string of ones and zeros. The physical layer of both the devices must also agree on a signal conversion so that ones can be distinguished from the zeros and both. So, okay, this was all about the 7 layers that we used in the OSI model. And this is the flow diagram as to how it happens. From the sender, all the data through the layers is encrypted. When the encryption, this happens from the sender to the through the OSI stack, the data is encrypted. And when the receiver receives it, it goes from bottom to the top. That is from the physical layer to the application layer. Once the data is sent from the sender, it goes from the application layer to the physical layer, and the encryption of data happens. Various headers in basically are applied. Like in the presentation layer, the physical header is added. In the session layer, the session layer is added. In the transport layer, the transport header is added. In the network layer, the network header is added to the data. The data link layer, the data link header, as well as the data link trailer is added to the data. Also, when it goes down to the physical layer, it's converted into bits. And once it is received by the receiving host, what it does, the physical layer basically takes out the physical layer, takes this stream of bits of ones and zeros. Data link layer basically detaches the data header and the data trailer. Going up the network layer, the network header is basically taken out. Likewise, the data transport header is taken out, the session header is taken out, and all these header basically data is transferred to the application as it was sent by the sender. So this was all about the OSI. I hope I was able to clear some of the confusion that you might have, and you might have a better understanding of what the OSI is. If you find this video helpful, kindly do share, like, and subscribe, and have a good day. Bye bye.